Next time you're standing on a train platform or you're watching a train roar through a crossing, do one small thing. Look down. Under those thick steel rails and those heavy ties, you'll almost always see the same sight: rocks, a ridiculous amount of rocks. Gray, sharp, jagged chunks stretching on and on for miles, like the railroad is basically built on an endless bed of stone. And if you were one of those kids who used to hang around near the tracks, you remember these rocks very personally. They're the kind that somehow find the exact soft spot in your shoe and stab your foot like they're proud of it. What's wild is, it doesn't matter where you are. India, the UK, the US. You look under the track, and there they are. Every time. So at some point, you have to ask, why? Why would we put something as modern as a high-speed train on top of a pile of loose rocks? Why not bolt the rails down onto a solid concrete base and call it a day? Wouldn't that be safer? The answer isn't just because it's cheaper. It's actually a really smart engineering move that helps keep tracks from slowly sinking into the ground. And it hides a surprisingly good history twist, one that connects modern railroads to old sailing ships. Welcome to Simple But Surprising. Today, I'm going to show you what those track rocks are really doing. So what problem are these rocks solving? Weight. An almost stupid amount of weight. A loaded freight train isn't just heavy, it's the ground has to negotiate with physics heavy. You've got locomotives up front, and then car after car carrying steel, grain, containers, moving as one long, rolling mass. Now imagine putting all that weight straight onto bare soil. Even if the dirt looks solid, the pressure isn't spread out nicely. It concentrates under certain points, the ground compresses, and the track starts to sink unevenly. A little dip turns into a bigger dip. A slight tilt becomes a real alignment problem. And when rails aren't perfectly aligned, trains don't politely complain. They derail. That's where the rock layer comes in. Engineers call it track ballast, and it's basically the track's foundation, shock absorber, and bodyguard all at once. Here's the simple picture. The steel rails sit on the ties, and the ties sit on this thick bed of crushed stone. The ballast takes the train's weight and spreads it out. Instead of the force punching down into a few narrow spots, those rocks distribute it across a wider area so the ground underneath doesn't get crushed like you're standing in wet mud with high heels. But there's another sneaky benefit, and it's the part most people don't notice. Train tracks aren't supposed to be bolted into the earth like they're part of a building. They actually need a tiny bit of give. Not loose, not wobbly. Just enough to handle the constant pounding and vibration from trains passing over them all day. Because every wheel rolling by sends a shock through the system. If everything were locked onto a perfectly rigid base with zero flexibility, that stress would build up in the rails, the fasteners, the ties, until something starts cracking, loosening, or warping. Ballast lets the track settle and absorb energy in a controlled way. The track can move microscopically and then return to place instead of taking every hit like a statue. And steel has another habit. It expands when it's hot and contracts when it's cold. So rails are constantly dealing with temperature changes. If the track had no way to relieve that stress, you can end up with rails buckling in heat or pulling and straining connections in cold. The ballast bed helps here too. It spreads out those thermal forces and keeps the rails stable, so you don't need big gaps everywhere just to stop the track from warping. And there's one more modern bonus, especially in cities. Ballast can also soften how much noise and vibration travels outward. It's not magic, trains are still loud. But that rock bed helps absorb some of the shaking instead of sending all of it straight into the surrounding ground and nearby buildings. Now, all of that sounds great, but it comes with a trade-off. This isn't a build it once and forget it setup. Because the whole system works, partly because it has that tiny bit of give, over time, those rocks can shift and wear down. They do shift, just slowly. That's why railroads keep up with ballast on a regular schedule. After enough trains, the stones start wearing down, fine dust builds up, water doesn't drain as cleanly, and the track can lose that even, solid support. So companies use these wild-looking machines that lift the track slightly and pack the stones back underneath, a process called tamping, so the ties are sitting evenly and the rails stay true. It's one of those jobs you only notice when you're stuck waiting and thinking, why is this train moving at the speed of a sleepy turtle? So yeah, those rocks aren't just there. They're keeping the track from sinking, helping it absorb vibration, keeping the rails stable through heat and cold, and even cutting down how much shaking makes it into the world around the tracks. And that brings us to the next question, because the shape of these rocks is not an accident. Why are they jagged and sharp instead of smooth and round like river stones? That's where things get really interesting. At this point, you might be thinking, all right, I get it. The rocks support the track, but why do they have to be these rocks? Because if you've ever picked up a piece of ballast, you know the first thing you learn isn't engineering. It's pain. These stones are sharp, jagged, rough. And along train tracks, you'll notice what you don't see. Smooth, round river pebbles, the kind that look harmless. That's not an accident. That's the design. Picture trying to walk on marbles. Everything slides. Nothing stays put. Round stones behave the same way. They roll. And under constant vibration, they keep shifting around. Now put a train on top of that. Every wheel that passes would slowly stir the rock bed, leaving uneven support under the ties, until the track starts drifting out of alignment. So engineers use crushed stone, often hard rock like granite or quartzite, broken into sharp, angular pieces on purpose. Because angular rock doesn't roll, it locks. When you lay a thick layer of those jagged chunks and pack them down, the edges grab onto each other. Corner bites into corner. They key together like a rough puzzle, creating a base that's stable and strong while still having just enough spring to absorb vibration. That interlocking grip is what keeps the track from sliding around. Even when a high-speed train hits a curve and sideways forces try to shove everything outward, the ballast holds its ground, so the rails stay put, the ties stay seated, and nothing slowly drifts like it's on roller skates. So yeah, those rocks are sharp for a reason. They're basically the track's built-in grip. And it's not just the shape that's carefully chosen, the size is too. Ballast stones usually land in a pretty specific sweet spot, roughly about 1 to 2.5 inches across. Big enough that they don't get crushed into dust right away, but not so big that they turn into awkward boulders that won't pack together under the ties. That medium size lets 3 things happen at the same time. The rocks lock together, they still leave open spaces for water to flow through, and they stay tough under constant pounding. That's also why railroads tend to use really hard stone, stuff like granite or similar rock, because this is a surface that gets hit, vibrated, and ground against itself for years. Softer rock breaks down faster and turns into the fine, gritty material that causes headaches later. But ballast isn't just there to hold up weight. It's also fighting 2 of the railroad's biggest enemies, water and weeds. If you put tracks straight on dirt, heavy rain turns the ground into mud. Mud shifts, washes out, and suddenly you've got a section of track sitting on not much of anything. And if you go the other direction and build a solid concrete base, water can pool and hang around, never a great long-term plan for steel instability. A bed of rocks does something way smarter. It drains. All those gaps between the stones act like a giant built-in drain system. Rainwater slips right through and moves away instead of sitting there. The base stays drier, firmer, and a lot less likely to get eroded when weather gets rough. And then there are weeds. You almost never see a lush little garden growing between the rails because this sharp, chunky rock layer makes it really hard for plants to take root. And that matters, because once roots get established, they start messing with the ground underneath and breaking up the stable foundation the track depends on. So ballast ends up doing 3 jobs at once, supporting the track, draining water, and discouraging weeds, all while looking like it's just minding its own business. And before we wrap this up, there's one last detail that's genuinely surprising. Here's the fun part. Why is it even called ballast? That word didn't come from railroads, it came from the ocean. Centuries ago, wooden ships would sometimes leave port too light. And a light ship is a sketchy ship. It bounces, it tips, it gets pushed around by waves, so sailors would load heavy stone into the hull as extra weight, basically to keep the ship steady. That weight was called ballast. Then the ship arrived to pick up cargo, and they'd dump those stones on shore to make room. Over time, ports ended up with piles of spare rock just sitting there. Early railroad builders needed something that was heavy, cheap, and stable to support tracks. They saw those dumped ship stones and went, yeah, that'll work. Same rocks, same job, stability, and the name stuck. Now, some newer high-speed lines use a concrete slab track instead because it can handle extreme speeds with less routine maintenance. But most railways around the world still run on ballast because it's cheaper to build with and easier to repair almost anywhere. So next time you spot those sharp gray rocks under a set of tracks, you'll know they're not there just because. That stone bed is doing real work, draining water, discouraging weeds, spreading out massive weight, and quietly keeping trains running safely and smoothly day after day for generations. This is simple but surprising channel. If you enjoyed this little hidden world tour, hit like, subscribe, and tell me in the comments what everyday thing you've always wondered about but never looked up. Thanks for watching, and I'll see you in the next one.